Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please like, comment, and share in your favorite podcast app. And we'll keep sharing great conversations like the one we have for today. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. I'm also an investor in and advisor to more than 30 AI-first companies. And as you know, a firm believer in the power of technology to make humans better. If you're passionate about changing the world with AI, or maybe just ready for your next adventure, let's talk. Now, we learn from AI thought leaders weekly on this show. And of course, the added bonus is you get one AI fun fact each week. Today's fun fact, we've been talking a lot about LLMs, or large language models, on the podcast almost every week recently. And one novel new approach to LLMs is called PETALS, the acronym PETALS, that daisy chains together various LLMs using peer-to-peer networking. I thought this was fascinating when I read about it this week. The open source project could lead to potentially the largest LLM ever developed. The way it works is each participant hosts subsets of model layers on separate GPUs. Separate clients in a peer-to-peer model then use queries that span multiple hosts. The researchers behind PETALS claim it significantly reduces the time to process queries, and obviously the computing resources required to train large LLMs. So far, PETALS has successfully demonstrated a 100 billion plus parameter model split across hundreds of connected servers. And they anticipate it will soon be the world's largest and fastest ALM. I will eagerly be looking for more information about PETALS. It's a unique approach. And as always, we will go ahead and link to the full article in the show notes. But shifting to this week's conversation, developing software is a task reserved for, call it the less than 1% of the planet who have the technical aptitude, academic credentials, and patience to teach computers. Or at least that's what we used to think. The term citizen developer was popularized in the past decade to shift tasks historically reserved for programmers to everybody else. No-code app dev platforms like a QuickBase or an OutSystems or Mendix are now being challenged by a whole new generation of tools that are even more intuitive. Someday, we may all be building apps using nothing but natural language prompts. Well, today, we get to learn how the worlds of app dev and generative AI are colliding. Binny Gill started as a programmer after studying CS and engineering at IIT Kanpur, and later UIUC, the University of Illinois at Urbana-Champaign. He then had an impressive 8-year run as a technology leader at Nutanix, the hyper-converged infrastructure company, eventually becoming its CTO for cloud services. In January of 2021, Binny left Nutanix to start Kognitos, based on a bold vision to make everyone a programmer. Today, we get to learn about his journey and how generative AI just may change everything. Thanks to Steve Kaplan, a mutual friend of Binny's and mine, for the intro. And without further ado, Binny, welcome to the podcast. Let's get started by having you share maybe a little bit more about your background and how you got into this space.
Hey, Dan, thank you for having me on the show, and thank you to everybody for tuning in. Yeah, I mean, all my life, I've been a student of computer science. I started off with security and distributed systems a couple of decades ago. That was before IoT was a thing. I was tinkering with controlling access to a television and microwave using Java. And that was fun. But I dropped out of my PhD to jump onto the dot-com boom, only to see the very end of it. And well, I started in security and storage systems. I got interested in caching algorithms. I went into IBM research. I did a whole bunch of consumer flash in enterprise storage. And what brought me to Nutanix was the ability to bring solid state to applications so that applications can get faster and smarter. And in my 8 years there, I learned a lot about building business, but also learned a lot about different types of computer science technology, hypervisors, cloud services, automation. And in my career, I've learned so many computer programming languages, and each language was supposed to be better than the last. But I've always had this strange dissatisfaction with the experience of programming. And there's been a big gap between what I want the computer to do and what I have time to tell the computer and teach the computer. And then something happened during the pandemic where it changed everything for me. And I want to bring that change to the world.
Binny, you're the first technologist ever to say, as a programmer, I don't like programming. And that's what I like about the vision that you have for Kognitos. What would you say is the future of automation that led you to found the company?
The future, just like, think about reading and writing. In the dark ages, very few people could actually write a book and give it to others to spread their ideas, right? And we've had a transition from those dark ages to today where everybody can read and write and we can spread our ideas freely. We democratize the ability to write our ideas and distribute it around the world. Will that same thing happen with computers and programming? That's the question I asked myself. Hey, I know how to program and I've been doing it for so many years. And I got that insight. There was a day during the pandemic, my 12-year-old son was trying to write his first ever program. It was in Python, and he was writing his a game of tic-tac-toe. And he took a couple of days and wrote it, and I was a proud father. I said, okay, my son did that. I slept. I woke up to that same strange feeling of dissatisfaction, except it was very, very deep because my son was involved. Is that I just remembered I wrote the same program in BASIC 30 years ago at the same age, and it took me 2 days even back then. So see what happened. In 3 decades, the act of programming did not improve by even a single bit. And I was like, I always thought computers have become a million times faster and more powerful. So what is it that we have really achieved? And I went back to my son and said, you know what, let's sit down and let's write another program. I want to see, why is it hard for somebody to tell a computer something new to do, right? Because I've forgotten all about those pain points. I know so much. And we wrote another program, and I saw myself telling my son these things. Write down a pseudocode in English, and below that you will start writing Python. And I repeated to him, think like a machine. The for loop, that is sort of fundamental in computer science, how do you loop over something, was alien to a first-time programmer. And it's like, what? Like, and like I said, think like a machine, step by step. Kept on doing it. And then I realized it's not getting easier. I mean, it's not that the language is wrong. Every language will ask the user to do the same thing. And I asked my son, okay, what would work? And he came back to me and said, hey, why can't this pseudocode work? That's in English, I asked him to write down notes. So why can't that work? And I said, no, that does not happen. I mean, come on. He said, no, Dad, like Alexa. And I was like, oh, I didn't have an answer. I thought that was a challenge to me. It's like, if Alexa can do a single line of code in English, why can't I build a system that can do 10 lines of code, 100 lines of code, 1,000 lines of code? And he was right. I mean, why should somebody go through and think like a machine where machines are starting to think like humans? And that was the genesis of the idea of Kognitos. What I wanted to do and see if can we provide the ability to teach a computer something new to everybody, not just programmers. And that journey, I mean, it was 3 years ago, and today we are sitting at a point where, yes, that is true. And if you look at what ChatGPT is doing, it is creating that next generation of evolution for automation for the whole world.
So Binny, in 30 years, how will your son's son write the program to play tic-tac-toe?
Well, 30 years is a long time. If you look at what's happening today, we are at an exponential curve for what AI can do. So I wouldn't even go and talk about 30 years. I'd probably talk about just 5 to 10 years, right? So teaching a computer something is an unnatural thing for humans today. What's happening is computers are becoming more like humans. So in reality, we have to unlearn all of computer science. Computer science is a science that tells us here is a machine, it understands some machine language code, and how do you talk to it? You being a human. If computers are now with the power of AI being able to understand what a human wants, then we don't need to learn anything new. We just use what we do with other humans. I talk to another friend, hey, do this, get me coffee. And he goes to the kitchen and say, hey, Benny, do you want sugar? I say, oh yeah, put sugar. And then he goes, did I program? Do I call it programming? No, right? So in just 5 years, what will happen is you're talking to a computer and just describing what you want, and the computer is gonna do it for you. There is a big insight I got 6 months into this project. So I said, okay, I'm gonna write a game in English, which I did. It was a ball that bounces on the screen, and there are bricks that go away, right? Now I wanted to do it in a way that does not require the person using English to think like a developer. The first insight I got was, you know what, it's not really the choice of language that makes programming hard. It's the fact that the machine likes to crash anytime you forgot to write an instruction that it needed in a particular corner case. Humans are different. Say, human goes to the kitchen, oh, do you want sugar? So that was a parameter that I forgot to mention. There was no crash. The human reaches back and engages in a dialogue. Computer systems so far, in fact, there is no programming language that engages in a dialogue during runtime with the programmer, right? That's one thing that had to change. And going all the way back to lambda calculus, at the time of Alan Turing, Alonzo Church, he came up with lambda calculus. That's the foundation for all computer languages today. And that says there is a function, you want to call it, you give it a parameter, X, function is F, and out comes Y, right? It's basic. All of computer science is like that. Now, what happens if I call X and I forget to give X? Well, computer crashes. For 2 generations of people in computer science school, we have been taught that yes, obviously, if you forget to give X, it's going to crash. It's stated as if it was a rule of nature. But in reality, if you want to make computers behave like humans, you should be able to call F without giving X. And the system should say, hey, you know what, I need X. And oh, by the way, I might also need a Z and an A and a B, whatever. That's the dialogue. So programming has been missing dialogue. And that was the first insight I got. So it's not just about making it look like English. It's actually being able to enter a dialogue of progressive information. You give the system more and more information as the system requires it. And the smarter these systems get, they'll ask lesser questions. So in 5 years, you could say, hey, write me a game of tic-tac-toe. And it might say, hey, you know what? I'm going to write it this way. Explain it to you. And you say, no, I want, the visuals to be more like black and white or color or something. You can just add more nuance to it. But most of the decisions it could take for you. So in 5 to 10 years, You're not programming computers, you're just talking to another intelligent thing and explaining what you want. And then there's a dialogue to understand the nuances that might be needed. And off you go. And everybody should be able to do that, not just software engineers.
I mentioned in the intro that as much as a decade ago, there was the rise of these low code, no code platforms. Now, even sometimes we group in RPA platforms, robotic process automation platforms with those. And those were supposed to solve the problem of taking whether, a form or some kind of GUI and attaching it to some business logic, and then all drag and drop, WYSIWYG, right? And then maybe layer in some workflow, and your quote citizen developer can publish an app that automates some simple task. Where did we fail along the way?
Yeah, and what you said, there are many words that point to the failure. One thing is we talk about drag and drop. When one human wants to communicate with another human, like what do I do? So when Dana wanted to talk to you, I sent you an email. Did I use drag and drop? No, I used English. Why? The fact that an interface to a computer is different from the interface to a human points out to us that there is a weakness in the computer. And you know what the weakness is? The computer likes structured instruction. And that structure is very precise. To teach humans that precise language is a lot of work. And that's why developers are paid a lot. So instead of teaching the human the precise language, we give a drag and drop. So, it's easier for you to drag some things, but they result in a precise instruction to the computer. But what that creates is there's only a few choices. It's like you go to McDonald's, few things on the menu. It's easy. I don't have to tell you how much salt, how much that is all, but you can do a limited things with it. So drag and drop failed because there was just a limited number of things you could do with it. With citizen developer, the problem is we are asking the citizen to be a developer. My realization has been last 3 decades. We have increased the number of programmers not by making programming simple, is by just making humans learn machines. Now we start teaching kids in school early, this is how you talk to a machine, right? That's why. Otherwise, there has been not much progress. So asking a non-programmer or even a person who doesn't want to think like a programmer to do programming, no matter whether it's drag and drop or whatever you do, is not going to solve the problem. And that's where we drop the ball, in my opinion.
So let's take your time horizon of, call it 5 years, even less maybe. And let's say I'm in marketing and I'm trying to automate a process for taking trade show leads and putting them into my CRM system, just a basic task that maybe needs some lightweight workflow. How will I do that as a non-programmer in the next 5 years?
Yeah. So let me talk about what's already happened, and then I'll talk about what's going to happen. So ever since we started Kognitos, we've been working on making it possible for any business user to be able to express what they want in English. So you write the steps in English, and that becomes a language where both the machine and the human understand. This is the first time in computer science history where there is a program that any human can understand and the machine can also interpret and run it. While interpreting and running it, there are a few things that had to be invented that haven't been done in the past. One is natural language is inherently ambiguous and therefore inherently requires dialogue to clarify. So we built an interpreter that can do a dialogue to understand what you have written. And then you go off and execute it. While you're executing, if you think about the real challenge of programming is not about writing the happy path. It's about handling all the error cases, and debugging when things go wrong. In fact, people say don't write a program that is hard to write because you won't be able to debug it, right? Because that's 10 times harder. So what we have done is have the system help you in debugging as well. You need to be able to debug what happened in English as well. When an exception happens, it raises a question in English and explains what happened to you. And then you answer that. So there's a bunch of things. Now, these things have already happened. The technology is there to make it possible that there is a program in English that machine and human both understand. Now, that English that you tell the computer to do does have IT knowledge in it, if you think about it. Say, I want to add an account, new opportunity in my CRM. Okay, well, that's fine. A business user knows that. But then to do that, you actually have to log into Salesforce and give it a password and a token. Now, these things are IT knowledge. What's going to happen in the next year, I would say, is that using generative AI, we can remove that barrier as well. So business user talks to a large language model and says, I want to add a new opportunity in my CRM. And the large language model says, okay, what's your CRM? You say, oh, it's Salesforce. Okay, these are the things you need to do. Boom, boom, boom. And now that is a program that can actually be run. So the analogy there, I would give you an analogy. It's almost like when I go to my doctor's office. Okay. My doctor's office, I visit the doctor and she's probably 100 times smarter than me in terms of medicine. What's going to happen with large language models is that these AI models would be 100 times smarter than me at the job. Okay. Now the doctor says, okay, this is your diagnosis and this is our plan of action. We got to do this, take this medicine and all that. And then I don't blindly take that and say, okay, just do it. I still need to understand it. So she's going to explain it to me. This is why things are happening. Now I take that and take it to my pharmacist, who's just going to diligently do it. But in this whole process, I am in control. I call it the steering wheel in this new era of automation. So when there is an automation that is generated by generative AI, I need to be able to review it before I hand it off to APIs and downstream systems and it goes and happens. It's very similar to, for example, if you look at DALL-E 2 or Midjourney, I give it some, my wish in English, out comes a drawing. Now I still have to review it. Maybe it doesn't agree with my values or whatever, and I want to change it. If you look at the GDP of the world, most of the GDP is not related to these creative arts of, creating art or essays and so on. It's actually coming from driving the machines that we have built in the industrial age. Now, driving these machines is something that we want to be very careful about. If we give the keys to these machines to AI, then we are talking about AI taking over the world. Instead, there needs to be a system where AI can propose a plan just like my doctor, but I am in full control. I understand the plan. Then I take that plan in a language that both I and machine understands, and the machine goes and diligently does it in a way that I can later go and figure out why things happened. If something went wrong, I can go and handhold and fix that. So that's what's going to happen. I think in the next 5 years, we'll see all of that happen. And then beyond 5 years, we'll be talking about how do we handle AI that is much smarter than humans. So as an analogy, in the industrial age, we started off with electricity coming in, and now we could build machines that were 100 times more powerful physically than humans. Say, okay, you have 10 horsepower, 100 horsepower, 1 million horsepower. So In terms of physical labor, we got rid of it with electricity, but we always had the steering wheel or the cockpit or the control panel in our hands. And that made us feel safe with that, even though these are really powerful systems. Today, generative AI is the new electricity. And this is going to take away mental labor. Okay. But the question that we'll answer in a few years is, what happens when the mental capability is beyond one human? The same thing happened in industrial age. So it's one brain power, 100 brain power, million brain power. And where is our steering wheel? Right. And I think that's the question that society has to answer. The slippery slope, if we do nothing, is we give AI systems the keys to our machines just because they are 10 times or 100 times more smart than humans. Imagine today computers are smarter than humans at playing chess or AlphaGo, so they can strategize better. So what goes to say that AI cannot strategize my business better than my CFO or my CMO, right? Yes, it could, but then that's the slippery slope. A business will use that in order to get an upper hand on their competition, except if there is no human review, how do you trust it? And that's what I'm passionate about. We need to build a safe future for AI, for our society. And the only way I see beyond, just in the next few years when AI becomes smarter than humans, is we humans need to be on the driver's seat and use AI like it was a 100 horsepower car or whatever. It'll still do what we want it to do. And the way to do it is we don't give direct access to APIs to generative AI. Generative AI can come up with a plan. I review it, and then I hand it off to a diligent system, which is also AI based, but that's more like a pharmacist. It might do a few tweaks here and there. Hey, we are out of stock here. What do you want? And stuff like that. And that's how we can harness the power of superhuman AI. And I don't know what's going to happen in 30 years. We'll be beyond the singularity. So I'm just talking about just the 5 years.
So here we are taping this in January of 2023 in the cradle of Silicon Valley. And as we are wont to do in Silicon Valley, we picked a technology and we decided that it is the solution to every problem. We aren't even always good at articulating what the problems are, but we've decided what the solution is. And it's now called an LLM, and it now has a name called ChatGPT. Yeah. So I want you to take the cynical side of that. And I'll frame it by saying, I'm not convinced about the example that you gave that we'll use in the future. We'll use LLMs like ChatGPT to automate the financial management process or to automate the role of a CFO. Because one concern I have is that if my competitors are using the same LLM that I am to make the same financial determinations, everyone's strategy looks the same. And everyone's writing will be bland because we're all using the same prompts to generate. So you can see how this could spiral. Now, obviously, I'm of a certain opinion here, but I'd like to hear your response to what are the limitations of LLMs and specifically ChatGPT that we should be aware of in this future that you've described.
Yeah. No, so one quick answer to how everything's going to look the same for every company. No, the reality is, just like I could hire a great exec in my company versus the same exec could be hired by my competition. But really, their effectiveness also depends on what's inside the company. So ChatGPT in the future will be looking at your private business data and running inside your business. And then I'm sure there'll be a bunch of startups who come up with this ability that you could have your own models. There should not be one model serving the whole world. I feel we are building the AI grid. Just like there's an electricity grid out there, there's an AI grid. And AI, the power of AI will come from many different places, including you'll have your own AI models built on your own business data, right? So therefore, the benefit that you get from ChatGPT will vary based on what your business is doing. Now, what are the weaknesses? Think of these large language models as dreaming machines. So they are trying to complete a sequence of things that should make sense. They're plausible, right? In our humans have an intuitive aspect and a creative aspect in their brains, and then there is a logical and diligent aspect in our brains. We call it left brain, right brain. ChatGPT is all intuition, so all creativity. So if you're running a business, you don't want to just run it on gut feeling or intuition. You want a mixture of creativity, intuition, as well as business process. Businesses are very heavy on processes. We write down things, we want things to happen in a certain order. And even when you hire employees, you tell them, hey, these are the business rules that we need to follow. So what we actually need is a combination of the two. Now, what I predict is going to happen is when there is a problem, when there is a need for creativity, when there's a brainstorming meeting in a business, that's where ChatGPT comes in, and it'll allow you to explore what's possible and what's probable. However, it will not have the same moral values and the same understanding of what the business needs. And therefore, the human has to review all those things and say, okay, I got one idea from ChatGPT, but this is what we will do. I think that's the sane future. The other thing is, other alternative is people start training ChatGPT to also have human values and human emotions and stuff like that. I think that's very controversial, and there'll be a lot of ethics issues with that.
Binny, that's the start of a whole other conversation, and we're going to have you back to pick up there. But we're about out of time. But I gotta get in one last question for you. You've been at some amazing companies, IBM, certainly legendary. Culture. You were influential in helping Nutanix grow. I'd love to know what leadership lessons you've taken from the places you've been that have helped you build Kognitos to this point.
Most important lesson that I have learned is people are the biggest piece of the puzzle. If you have to build anything, a company or whatever, the people are the biggest piece of the puzzle. But one thing more important than people is the collective culture they create. Now, there is no culture without people, and therefore people are the most important thing. But you could have the same set of people and the culture could be different. So as a leader, the biggest thing to worry about is what is the culture of the company? That's sort of the DNA of the company. And everything you add to the company is going to continue with that culture. If you can get culture right, that'll attract the right set of people. If you have the right set of people, you will build what's needed. Technology is a byproduct of great people.
Good wisdom. Thank you for sharing that. Binny, we're out of time, but where can our audience learn more about you and your work?
At our website, kognitos.com, and we have a bunch of blogs that I've written over the last few months on just the journey of how the notion of interacting with computers is changing, how everybody in the world will soon be enabled to be innovate through machines. That right now, just a handful of people, 1 in 200 people know how to interact with the computer. That has to get democratized. Everybody will get the power of innovation back in their hands. And just like DALL-E 2 made everybody an artist, ChatGPT made everybody a great essay writer, Kognitos will make everybody a great programmer.
Well, Binny, we're all rooting for you to succeed. I really enjoyed this conversation. It inspired me, and particularly the topic that you left off on at the end about the ethics of how some of this stuff gets deployed. I think that's a really important conversation, and I would love to continue it with you in another conversation.
Happy to do so.
Well, gosh, that's it for this week on AI and the Future of Work. As always, I'm your host, Dan Turchin, CEO of PeopleRain. And again, thank you to Steve Kaplan for putting Binny and I in contact. I love this conversation. And of course, we're back next week with another fascinating guest.